So welcome everybody. My name is Jeremy Walker. I'm a Cisco product sales specialist for the data center. I am stationed out of the St. Louis office, but I cover Metro St. Louis, Southern Illinois, and all of Indiana for what we consider the mid-market territory. Today I want to spend a little time kind of going over Cisco's new vision for the data center. So last year, many of you may have heard the messaging around the multi-cloud data center. While that's still a valid message to us, we realize there's a lot of customers who aren't necessarily looking to move to the cloud. And in many cases, I've had customers who have moved to mega clouds like AWS and Azure and are actually in the process of moving back now because they've realized that while there's some agility gained by it, long-term financially, they do end up paying more money to rent those resources from AWS and Microsoft. So as part of the intent cycle, the real goal around the vision is getting out of the day-to-day operations of typing in commands to switches, setting up switches from terminals as we've done for many, many years. I myself, this is the 18th year for me in the data center. So I started with Sun Microsystems in the data center. So for any of you who are aware that it's a great company that is no longer with us now that Oracle bought them. So I've been around, right? So I've seen ATM, I've seen token ring, I've seen Ethernet, and we've kind of transcended that point now where we're looking to get out of building networks from running commands and tying individual switches together. Things like spanning tree, EGIRP, BGP, all these routing protocols, all this interconnections, we're still traditionally relying on a human to understand how the network's being built out. And the big buzzword these days is software-defined networking. So my nearest and dearest competitor has built a product that still requires that their software-defined networking runs on top of a physical network that's being built out by hand. When we looked at building Cisco's ACI platform, it was more about building a software-defined network that also included the hardware. And the reason being is, if we build a software-defined network, but we're still beholden to the underlying hardware, if there's a configuration issue with that underlying hardware transport, your software-defined network is going to be affected by it also. So one of the principles of Cisco's ACI platform is, when you go to install it, we've actually gotten to the point now that when the ACI fabric is deployed, it's a matter of interconnecting the switches through the cables and powering them up, and they will actually start to auto-discover themselves. And they will build their own fabric to then run the transport layers. So the interesting thing about this is if you have an ACI fabric and you try to log in and configure the network manually, the switches will actually not allow you to do it. So many of us who have configured switches in the past, you'd get on the terminal, type config T, and you'd go in to make your changes. In an ACI fabric, if you try to do that to one of its switches, it'll actually tell you that no, you cannot, because it's all being managed via software. Additionally, ACI was kind of built around the fact of the application is more important to the business than the actual network itself. So, you take a step back and you look at, as we continue to iterate through how data centers and applications are designed, AWS and Azure kind of forced us to go back and look at a zero trust network from the standpoint of back in the day when I switched to x86 administration, I was a Novell admin, and you started out with nothing trusted anything. You could actually create permission black holes because it was so locked down. But then Microsoft came along and they made it much easier for everybody because everybody trusted everything day one in Microsoft world. And so over time, we kind of moved away from that zero trust into a more open network. Well, the problem is now with bad actors getting into our network, with everything being open, it's much easier for them to leverage somebody's workstation to then traverse into the data center and start infecting or stealing data off those servers. So ACI is really focused around encapsulating both virtual machines, physical machines, and providing that security layer, because now inside of the ACI fabric, instead of defining how the network is built via switch configurations, we define how the network's built based on communications between things such as SQL servers and middleware servers, and then from those middleware servers back out to other applications or end users. And then just from a high-level infographic slide, it's really about taking the human's hands off the keyboard and empowering the machines to make the decisions, right? So in an ACI fabric, I have seen at multiple customers where things such as GBICs have gone bad, cables have gone bad, and the environment itself has healed and worked around it. Because now that we have machines watching the configuration and modifying the configuration, no longer are we beholden to waiting till an admin sees the alert. Now the machine can actually adjust and adapt itself as it sees fit. So I know that we've been talking about Cisco's ACI now for, probably the last 6 years. Does anybody have any questions on it? Is this a new message for anybody? Like I said, I know we've been talking about it for 6 years, so I kind of run through it pretty quick just on what our vision is today, but I'm happy to address any concerns that you all may have. Nope. All right. We'll move on because they only gave me 15 minutes, so we're going to blow through the rest. Cisco's Tetration platform. So I used to do business continuity and disaster recovery. And one of the problems I always had was that the application owners could never actually tell me how the application worked. They would go out, they would buy an application, they would install it, we'd run it 18 months, and then they'd be like, okay, well, we need this thing to survive a disaster. And I'd say, well, okay, that's great. How does it work? No idea. Same problem came into when we started deploying ACI for customers around the world. In order to get to that application-centric design, you have to know which ports and what protocols all the different servers are talking to different components of. And so it became a stumbling block for a lot of our customers initially of, I want to deploy this, it's important for my business because it's going to add that security that I need, but I'm failing to get it implemented properly because no one can provide me with the required documentation. So we built Cisco's Tetration platform to address that. Originally, we had to obtain the data through traffic flowing on Nexus 9Ks. The original iteration of this product was $1.7 million. So as you can imagine, everybody was knocking on our door. It was like iPhones. They were lined up around the block to buy it, right? They weren't. Fortune 100, I think approximately 50% of them purchased it. But it was important to us, and it was important to our customers. So we eat our own dog food inside of Cisco, and we went to our internal IT team, and we said, hey, we got this great idea. We're going to put agents on all the servers that Cisco has under their control for their company. And as you can imagine, the server admins for Cisco were open arms, ready to install yet another agent on their server. And all the server admins in the room are giggling right now because they know that's not the answer that we got originally. So internally, the server admins said, okay, we're going to give you an SLA. If you can keep it under 3% of CPU usage, we'll put the agent on. So the developers went to work. They actually beat the SLA. The original iteration, they did it in less than 2% of the CPU. Fast forward to current standards, we actually allow our customers to set the SLA inside of the agent itself. Most of my customers select between 1% and 3%, depending on what other agents they have to run on the servers. But the reason that we wanted to do this is because now the Cisco Tetration platform is completely hardware agnostic. So I have customers who run HP hardware, that run Dell hardware, that run Cisco hardware. I have customers who use Tetration inside of AWS and Azure. And what that allows them to do is understand how the traffic's flowing, not just in the data center that they own, but in any one of the mega clouds. And allows them to have fine-grained control on how that communication is working, and allows them to map how those communications flows so that in the event that they have to move the workload to another cloud or to a new data center, they can move them together versus in pieces, which may induce additional costs. From a business use case, the three big ones that I see with my customers are mergers and acquisitions. So I have been an independent consultant previously, worked with a lot of banks. Mergers and acquisitions are usually very difficult for them because whenever you buy another company, one of two things happens. Everybody leaves for fear that they're going to lose their job anyways, or B, they really didn't know how their IT environment really ran from day one. So Tetration helps map those things so that if you have to ingest another company's IT environment, it does a lot of the legwork for you versus relying on possibly some outdated documentation. Setting up disaster recovery sites. As I alluded to previously, that was a big deal for me in previous life. The problem with disaster recovery planning is as soon as you get done with the documentation, it's already out of date. It's kind of like when you buy a car and you drive it off the lot and it's already lost value. Same thing with designing disaster recovery environments. And then the move to cloud-based environments. So if you go to Azure or AWS, you always want to move as many of the servers together as possible. And the reason being is the biggest dollar item that gets my customers is the traffic egress out of the mega cloud. You can run servers in there fairly cheap and you can get storage very cheap. Both Amazon and Microsoft have figured out that the cost to them is when you leave. So they charge you the most when you try to move anything out, be it data, be it network. Egress is always where my customers pay the most, so that's what they're focused on limiting inside of Tetration. And then finally, Cisco Workload Optimizer. This is a product that we've worked with Turbonomic on. So Turbonomic makes a software package that really focuses on making sure that our customers get the most bang for their buck out of the environment. As far as resources, it will look at CPU utilization, memory utilization, network utilization, and make recommendations on not only how to resize virtual machines, but how to realign virtual machines on hosts so that they get the most usage available. And one of the things that we can do with Tetration through REST APIs is we can actually take those traffic flows and feed it into the workload optimizer, and it'll group chatty applications together. So for example, if you have a 3-tier architecture and there's a lot of transactions that run across it on a daily basis, we don't necessarily want to have all that traffic flow up and into the network if we can consolidate those virtual machines onto the same host. I have customers who have actually done this to alleviate the need to buy additional hardware at the network layer, because if they can take that chatty traffic and move it down into a single host, at that point it's containerized it and reduces the need for additional spines, reliefs, or core switching gear up above.